Hello, my name is Elizabeth Bennett, and this is my video lab report for our first lab in Physics 1211. The purpose of this lab was to compare observed and predicted data based on Newton's second law of motion. The observed data was obtained by sliding a whiteboard eraser across a surface, taking a video, and analyzing that video with the tracker software to determine the position of the eraser as a function of time. The predicted data was created using a glow script code that modeled the velocity of an object experiencing a net force of 0 based on the velocity observed from the eraser. As stated previously, the fundamental physical principle used in this lab is Newton's second law, which is force equals mass times acceleration, where the net force equals the derivative of position in respect to time, as shown by the equations on the slide. Based on the comparisons between the observed and predicted data, the lab resulted in a very similar path between both graphs of position in respect to time. However, there were some differences, such as the curve of the observed data not being perfectly linear. As was introduced briefly in the previous slide, the experiment in this lab involved a whiteboard eraser being slid across a flat surface at a constant speed and direction. The motion of the eraser was then tracked using the tracker software to obtain a position in the xy direction of the eraser as a function of time, shown in the graph in the lower right-hand corner. In the upper picture, you can see the red axes and blue meter stick that were placed as a reference and tracker to be able to accurately assess the motion of the eraser. The red dots shown along the eraser path are the tracked locations of the eraser as it moves through space. The system in this scenario is the eraser as it slides across the surface. The surroundings are the surface that the eraser is sliding across. The motion of the eraser was tracked starting when the eraser was moving at its average velocity throughout the time the experiment was run. Additionally, the tracking was stopped before the eraser began to slow down. This was done to prevent capturing any speed up or slow down time that would result in a variable velocity. The predicted data was created using a glow script code that models the motion of an object moving through space that experiences a net force of 0, meaning that its velocity is constant. The while loop used to model this motion uses an initial position and velocity to inform the next position and velocity. After the time increases by one increment, these new values are then run through the loop again and updated. This process runs iteratively until the while loop conditions are met and the loop stops. Because net force is 0, acceleration is 0, and velocity does not change throughout the code. Only position is being updated based on the object's motion at a constant velocity. Here are the individual components of the code are labeled. The mass of the eraser was 0.03 kilograms. The initial position is listed as well as the initial velocity. The total time of 0.6 seconds is listed as the parameter of the loop, meaning that the position will be predicted for the ball moving for 0.6 seconds. The position is updated based on the initial velocity. This is because the net force is 0, so the F net over mass times delta t term would become 0, and initial velocity would be equal to final velocity. Then time is incremented to allow the while loop to continue if it is less than 0.6 seconds, or stop if it is 0.6 seconds or more. This code was used to model the motion of the object as seen through this position versus time graph. The linear slope represents the constant velocity due to a net force and therefore acceleration of 0. Here the observed and predicted models are seen side by side on the same graph. The slopes are the same, although the predicted data is shifted a bit to the right of the observed data. Additionally, the observed data has a slight curvature, while the predicted data is linear. This is most likely due to the fact that the net force on the eraser was not 0 during its entire motion, as we cannot control the force of friction on the object in this scenario. If the axes were reversed on tracker, the magnitude of the velocity would remain the same, however the direction would be reversed, meaning that the velocity that has been shown in the position data would be negative. We can model the forces shown on the object, but we cannot count the total number of forces contributing to the net force with the naked eye. The goal of this experiment was to model an object at a constant velocity, so we assumed that the eraser had a constant velocity or net force of 0, which would require for the x direction the force pushing the eraser forward, which resulted from me physically pushing the eraser, to be equal to the force of friction pushing in the opposite direction. For the y direction, we know that the force of gravity pulling down on the object is equal to the normal vector of the whiteboard tray pushing up against the eraser.